options there. Let's close with something that's a bit more extensive. So given 3 points in three-dimensional space, a little bit harder to conceptualize and certainly to draw, and there's no need to actually draw this stuff, but you've got to get a feeling for it. So let's find vectors AB and AC respectively. We'll find their lengths. We'll show, in fact, that these two vectors are perpendicular to one another. That's building on our knowledge of the scalar product, and then we'll actually take a look at Pythagoras in the context of showing that it's actually a right triangle, a right angle triangle. So how do you get from A to B? Well, you get from A to B by working through the origin O. So wherever A and B are in space, you back up from A to O and add OB. That's kind of a classic thing to do. And AO as a vector is, of course, the opposite or negative of whatever OA is. Well, if the point is -2, -3, -4, the vector OA would just be -2, -3, -4 in column vector form. So we're negating that vector, adding OB directly to it, which would be the vector -6, -7, and -2. Notice these are vector forms, and they need to be treated as such, and they're different from Cartesian coordinate point forms. But they're certainly related, of course. And the negative of -2 is 2, and 2 minus 6 is -4. Here's 3, minus 7 is -4, and here's 4 plus -2 being 2. And similarly, same exact kind of thing here. How do you get from A to C? You get from A to C by bridging through O, and you get the idea. So we've got those two vectors, namely AB and AC. And once we've got those two vectors, the lengths of those vectors are not difficult. It's just the square root of the squares of each of these three components and the squares of these three added up. Notice I've been intentionally sloppy. -4 and -4 are not indicated here because -4 squared, which is 16, is the same as 4 squared, which is 16. So you can actually get a little bit careless in a good way here. That actually shows your examiner that you're stronger knowing that the square of a negative number is the same as the square of a positive number. So you get 6 and the square root of 369 respectively. And so you're asked to show, I believe, that those vectors are perpendicular to one another. Well, that would say or imply that their dot product is 0. And the dot product of looking at those two vectors in terms of what you've actually constructed there, you just need -4 times 3 plus -2 times 6 plus 2 times 18. And that's what you see exactly playing out here, here, and here. And those three arithmetic values sum to be 0, which effectively says since the dot product is 0, that implies that the two vectors are 90 degrees with respect to one another. Lastly, it's a little bit more involved. Since we have that AB is perpendicular to AC at point A, because they're sharing point A, you can see it right there, and we have the lengths, we know that there's some triangle being formed where right at point A, that's where there's the right angle happening. And so AB and AC allow you to have the two legs of whatever that right triangle is, and then getting from B to C would be the hypotenuse. And so how do you get from B to C? You once again work from B to O, O to C, and the construct on getting BC looks something like that, and the length of that would just be the square root of 7 squared plus 10 squared plus 16 squared, namely 1405. So there's some triangle floating around in space where we previously had the two legs, namely these two lengths. We already saw them on the previous panels. And then the sum of the squares of those two lengths better equal that hypotenuse, or the third side, because that's just Pythagoras. And here it is outlined for you right here in vector form. And as it turns out, 36 plus 369 exactly matches to the 405. Let's finish with something that looks a little bit more abstract, but it's not too daunting. Given AB, BC, and AC respectively as vectors, x, y, and z are in play here. Let's find those unknowns. Well, how does one do the construct? Well, how do you get from A to C? You get from A to C by working in this context through B. So again, AB plus BC is how you construct AC. We've seen that kind of thing before. So simply the addition of these two equaling AC. we'll say that x plus y is z. That's equation 1. Y minus 4x is negative 2. That's equation 2. And negative 2x plus 3y is 4. That's equation 3. You can see a system of equations, 3 equations, 3 unknowns. That's the golden number. They have to match up sort of 1 to 1. And equation 2 and equation 3 allows you to isolate, in this case, y is equal to 4x minus 2. And by virtue of plugging 4x minus 2 into the third equation where y is, you can reduce an equation that has 2 unknowns down to an equation with simply 1 unknown in terms of x. Solve, here's 12x minus 2 being 10x. Here's negative 6, add them across, and you've got 10. Divide, you've got x equals 1. And then by back substitution, x of 1 can conveniently go right there to be 4 minus 2 to give you y of 2. And then once you have y of 2 and x of 1, you can plug it in back here to get that z has to be 3. That's it. Hopefully that was a nice summary, and catch you guys next time. Cheers.